Hi everyone, and welcome to Jam Academy. A crate of mass 1,200 kilograms is being pulled up a smooth plane inclined at an angle of 30 degrees by a motor-driven cable at a constant speed of 5 meters per second. Remember that the speed is constant. The question A is, how much work is required to pull the crate a distance of 30 meters up the inclined plane at that constant speed? And part B of the question is, a motor of what power is required to perform this task? A motor of what power is required to perform this task? Now, let's start first by doing a free body diagram that illustrates the forces acting on the crate. We have the weight of the crate acts vertically downwards. The normal force acting on the crate acts perpendicular to the plane or to the surface. Is there friction? Did the question specify if there is friction? Well, I'm going to assume that the surface is frictionless. But let me advise you, if a question is silent about friction, do not assume that there is no friction. But the only reason I have done so here is because all the values are given except the coefficient of friction, so we don't have that. So I'm going to assume that the surface is smooth. Now, the next thing too that I would like for you to see is that this angle is theta, which means that we can resolve the weight of the crate into two components. You have the component parallel to the surface. This will be mg, the sine of theta, the component perpendicular. This will be mg, cosine of theta. So the very first question is, how much work is required to pull the crate a distance of 30 meters up the inclined plane? How much work is required to pull the crate a distance of 30 meters up the inclined plane? By definition, remember that work is defined as F multiplied by the distance moved, delta x, cosine of theta, where cosine theta is the angle between the force and the force displacement. Let me say that again, where theta is the angle between the applied force and the displacement of the point of application of the force. So, since the system is moving with a constant velocity, we will assume that it's really not an assumption. The sum of forces acting on the crate is zero. That means that that implies that the sum of forces along the x direction is equal to zero, and the sum of forces along the y direction will be equal to zero. If we orient our axis such that the x-axis points upward along the plane, this will imply that t minus mg sine theta is equal to 0, which means that t is equal to mg, the sine of theta. This gives us the magnitude of the force, the tension force, acting on the rope. Similarly, the sum of forces along the y direction will be equal to 0. What that implies is that n minus mg cosine theta will be equal to 0, which means that n is equal to mg cosine theta. Now, you need to ask yourself what force is responsible to pull the crate upwards. The force that is responsible to pull the crate upward is the tension in the string. And therefore, the work done to pull the crate upward will be given by W will be given by T multiplied by D, the cosine of 0, because the force is acting in the same direction as the displacement of the point of application of the force. So this is just going to be equal to TD. Hence, that work done will be equal to mg sine theta multiplied by the distance of the inclined plane, which I can just say mgd, the sine of theta. You can calculate the value of this force pretty easily. So W will be equal to M. I think M is 1200 kilograms. I'm going to take G as 10, even though it's 9.8. This is 10 meters per square seconds. D is 30. And if you multiply all of this, you have 1200 multiplied by 10 multiplied by 30. That gives us 360,000 joules. 360,000 joules, just to be sure. So this is the total work required. This is the total work required to pull the crate a distance of 30 meters up the inclined plane. Now, the next question is to add a model of what power is required to perform this task. A model of what power is required to perform this task. Bear with me that the average power is equal to F parallel multiplied by V. This will be equal to mg sine theta multiplied by V, which is equal to mgv, the sine of theta. So to put in the values, this will be equal to 1200 kilograms multiplied by 10 meters per square seconds. The speed is given, I think, is 5 meters per second. 5 meters per second multiplied by the sine of 30 degrees. So if we perform all the calculations, sine 30 is half. 30 sine is half, multiplied by 5, multiplied by 10, multiplied by 1200. That gives us 30,000 watts. So P is 30,000 watts. Now, just as a correction, we omitted the sine of theta. So you have here the sine of 30 degrees. So this will be equal to 360,000 divided by 2, which is 180,000 joules. 180,000 joules. Now this is quite a beautiful problem. If you have any questions whatsoever with regards to this problem, please do not hesitate to ask in the discussion forum below this video, and we will be able to help you. Thank you so much for your time, and remain blessed. Bye-bye.